Hello everyone, welcome to In 5 Minutes. In this video clip, we will discuss one question that was asked in December 2015 university question paper. The question is find equivalent resistance across terminals A and B of networks shown. You can see there are a lot of different resistors connected between terminals A and B. We have to combine them using series and parallel rules and find out equivalent resistance between the 2 points A and B. If you cannot proceed ahead with series parallel combinations, then it may happen that we have to apply star delta transformation. Otherwise, as long as we have any series or parallel combination of resistors available, we will keep combining resistors in that particular case using simple formulas of series and parallel combinations. So in this case, as you can see, these two 3 ohm resistors are in parallel first, so we can combine them, and once we combine them and replace them with a single resistance, that will come in series with this 4 ohm resistance. So I'm going to do both these things together in one step. So let's start with the solution now. If I redraw the entire circuit, I'm not doing anything with this 4 ohm resistance and also not doing anything with this upper 5 ohm resistance. And we can do one more thing. You can see 2 ohm and 3 ohm resistors are in series, so I can combine them and replace it with single 5 ohm resistance. So 3 parallel 3 is going to be 1.5 ohms, because two equal resistor values, when they are in parallel, the equivalent resistance will be half of that particular value. And this 1.5 ohm will come in series with 1.4, so we get 1.5 plus 4, that will become equal to 5.5 ohm. So in between the two 5 ohm resistances, we get the equivalent 5.5 ohm resistance. Now please do the connections carefully. This branch comes and connects to this branch here, and then we have 3 ohm resistance available, and after that comes the connection of this lower branch, and this is my 4 ohm resistance along with this external 4 ohm, and this gives me two endpoints A and B once again. Now you can see that this 5 ohm and this 5.5 ohms are in parallel, so we can combine them. And once I combine these two resistors in parallel combination, the single equivalent resistance will be in series with another resistance of 3 ohm, so I can replace all of them with single resistance. In the next step, we are going to combine 5 along with 5.5 ohms, and whatever equivalent resistor that comes into picture will be in series with 3 ohm resistance. So 5 parallel 5.5 comes out to be 2.619 ohm, and 2.619 comes in series with 3 ohm, so that gives me 5.619 ohms. So let us draw the equivalent circuit in the next step now. So this 4 ohm resistance remains as it is, and we have clubbed these two resistors with the third resistors, and that will become 5.619 ohm. And now you can see that this 5 ohm resistance comes in parallel, so this becomes 4 ohm here and this is 5 ohm here. So now all we need is one last step. These are my points A and B. In one last step, we will combine 5 ohm resistance with 5.619 ohm, and that equivalent resistance will come in series with 4 ohm on both the sides. So the next combination will be 5.619 in parallel with 5, and this will give us 2.646 ohms, and this 2.646 will come in series with two 4 ohm resistors, so that will overall become 10.646 ohms. So finally there is only one resistance left, which is of value 10.646 between points A and B. So that becomes my final answer. The question was to find resistance between points A and B, so RAB becomes 10.646 ohms. So nowhere we had to go for star delta transformation, because every time we could find two resistors either in parallel or series, so we can go ahead with that series parallel combination only.